Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences web protection platform. Signal Sciences, protecting applications, connecting teams. For more information, check them out at signalsciences.com/PSW. Onapsis is the leading provider of solutions to protect ERP systems from cyber attacks. Customers can secure their SAP and Oracle business-critical platforms from espionage, sabotage, and financial fraud risks. Visit them on the web at onapsis.com. The average time between being hacked and realizing you've been hacked is 1 year. Can you afford to let an intruder roam your network for that long? Can your company weather the fallout when this comes to light? Black Hills Information Security can find the bad guys in your network and train you to do it yourself. Email consulting@blackhillsinfosec.com to find out how a hunt teaming engagement can help you find a persistent threat in your network. Welcome back to Paul's Security Weekly. Whether you're phishing or hacking or spying, whether they're phishing, hacking, or spying, threat actors use domains and IP addresses to launch their attacks. The experts in this arena are domain tools. That's right. They've got an awesome Whois database that they've called and mined and managed over time. And some really smart people, Kyle Wilhut and Tim Helming, are giving a webcast. You can go to domaintools.com/Security Weekly and learn more, and you should, because they're awesome.
Heck yeah.
Heck yeah. So, my question, and Galen is here with us, intern
Yes.
Galen.
Hello.
Galen Alderson. Galen, welcome to the show.
Thank you very much.
And you are Larry's intern, and I'm sorry.
He's effectively the InGuardians intern, but
they assigned him to you.
But I'm his boss. In as much as that works, right? I mean,
and yet he's looking over your shoulder.
I know, it's creepy. But if you look very carefully at Galen's screen, you can see that there's the prime opportunity for Ceiling Cat to be watching him.
Yes, there is. So, Larry and Galen, you did a presentation at DEF CON.
Yes.
On something called VaporTrail.
Yep.
Back up. What problem were you trying to solve?
Right.
And, why should we care?
Great.
Before you get started.
So, and that's definitely part of some of the slides that we have put together as part of that. Because it wasn't so much that it was a presentation at DEF CON. It was a presentation at the DEF CON Demo Labs, which is very similar to the Black Hat Arsenal stuff.
Yep.
Where you get 2 hours and a booth and a screen. And you effectively give your elevator pitch every 15 minutes.
Yeah.
And, it was nice. It was one of the first times I think they've done something like this. Mm-hmm. So it was a much smaller audience. So we got to interact much better with the audience and answer a lot more technical, in-depth questions when they came up. Nice. So that was it. And definitely as part of that, we put together the 5-minute presentation, so then Galen could do a demo of the actual tool. And that was one of the first things that we put on the slides was what was the problem and why did we create VaporTrail to have this problem. The problem we have is that as doing penetration testing and red teaming and all of this type of stuff, one of the big things that we find is that we often need to interact with a beacon, or we need to exfiltrate data in some way, shape, or form. Mm-hmm. And without getting caught. And defenders are getting better and better and better and better at this. Mm-hmm. And we looked at all of the ways in which we were doing that exfiltration and found that every one of them had the ability for us to get caught, especially over wired networks out to the internet. We're making connections from a machine out to another machine. If given enough statistics and background, you can detect that.
Like offensive countermeasures.
Exactly.
Yeah, if it's on the network doesn't lie. There are packets. Correct.
Great. Right. So, great. Let's get a little bit closer in proximity to on something like a red team when we're going to be in physical proximity, and let's go deploy an access point in their environment. Well, they have rogue access point detection stuff now. They can tell that there's a new access point that just showed up, and they can tell it's connected to their network. All right, well, let's make a new wireless client. Let's turn on a wireless adapter in one of their machines that wasn't and make it connect to one of our access points. They can tell our access point was connected, is there, not connected to their network, but now one of their assets is connecting to another network.
And they can tell that.
They can tell that. So what's next? Well, you go and put your Dropbox in or something of the like to interact with and do data exfiltration with cellular CDMA or 2G or 3G, LTE, you name it. And that one is hard to detect. But it is becoming, based on some of the things that we start seeing about some of those types of environment, that is likely going to become easier to detect over time. There's going to be a lot. I think that there's going to be a lot more technology for us to interact with cellular technologies. I mean, we can already start to see. Right the day before DEF CON, there was a Python script release that was effectively an IMSI catcher with an RTL SDR. If your business is relatively static, like your same employees come in and day out, you can observe their MCs. And if a new MC shows up,
I gotcha.
Which would be a new unique device, then that may be interesting. That may be that's something you could detect.
Excuse me.
Yes, sir.
Your MC is showing.
Yes, yes, it is. As a matter of fact, it is. So we were thinking, and Galen and I were working on some other projects, and I sent him off on the tasks. I've talked about him being really smart and, coding in like 3 different languages in one day, and one of them he doesn't know very well. And we were talking about some stuff, and I said, it would really be awesome if we could take files out of a directory and send them in the air over something that there is no current detection methodology for, and that most people are not observing, and that would potentially be very difficult to detect because there's literally nothing in the environment, no corporate, no consumer offering, you name it, that could actually listens into these bands. And I thought about FM radio, standard FM, terrestrial broadcast FM radio. What happens if we can take data and send it outbound from the organization over FM radio? So that's what we did. That's what VaporTrail is. It's the ability for us to...
You were playing around with that stuff a couple of years ago.
So Galen actually managed to bring it to fruition. He's the brains behind the whole operation. I'm the idea guy. And he's way smarter than I am.
I don't know about that.
We're just smart in different ways. That's right.
You know that this is somewhere along the path of reinventing the wheel, right?
Oh, absolutely. Absolutely.
Okay.
Absolutely.
Right. Proceed.
Wait, what was the first wheel that did exfiltration over FM radio?
I can't tell you. I'd have to kill you.
So that said, there has been a lot of traditional methods for doing data transfers over radio, and specifically drawing on some of my experience with the ham radio stuff. There's lots of what they call digital modes, the ability to take data and transfer it over the air and do some reliable transmissions for some of that type of stuff.
Well, isn't it the theory that was some of the stations that broadcast the
number stations?
Number stations,
yeah. So number stations were sure, but they sent numbers, and we didn't know what they meant, and they were very much audio. So someone reading numbers. With the digital modes, it's effectively music tones, encoding data ones and zeros as to where it the waveform traverses,
right? Yep,
and so forth.
So not what you did.
Yes.
Yeah, that is what you did. Okay.
We didn't have it read numbers, but we had it do waveforms to encode data into digital data into an analog form,
and then back into digital data.
Right. Gotcha. So effectively what we discussed through going through all of this was Galen effectively developed a custom digital mode to deal with the hardware that we wanted to use to be able to transfer data over FM radio. Frequency modulated radio. There's tons of stuff on the ham radio side for doing this, but they're all well known, they're well documented, they're free. But it requires very expensive hardware to implement. Like, the cheapest I can think of is picking up a used ham radio for $300 or $400 off of eBay, and this is a big-ass radio. Then you need to find a way to connect a computer to this radio to get data to that, so then you're talking some other computer device.
You do a digital to analog conversion.
Exactly.
And then convert analog back into digital.
Exactly. So we were thinking about this and talking about how can we do this cheap. Well, we talked about in the past using a Raspberry Pi to be an FM transmitter.
You had something like that a while back. What was it doing?
It was doing music over or with a Raspberry Pi by toggling one of the GPIO pins on and off to effectively create a square radio wave with a piece of random wire for an antenna. Well, if it could play audio, there's no reason it couldn't play custom audio to create a specific waveform that's actually ones and zeros. So that's where Galen was able to. We effectively used the Raspberry Pi TX program, not something that we developed. Some folks had figured out that the toggling the GPIO was really great and accepts raw input.
But toggling the GPIO pins creates an FM transmission?
Correct.
Okay.
Yeah.
I gotcha. That's cool.
Now that said, go ahead.
Why FM?
That was the product that was readily available, and you could potentially tune into it with something very inexpensive. You could actually use your car radio in your car to potentially grab the data and find some way to record it and have a receiver with just about anything.
And what I mean is there's a spectrum much wider that you could be doing this on.
Absolutely. So the other reason why we picked FM radio, and specifically in the FM radio broadcast band, is that here in the U.S. and many other countries, a consumer is allowed to operate a low-power FM radio station. So think about when you're sitting in your older car that doesn't have the aux in on the stereo. You can get audio to your stereo from your Discman. Right, dating myself, right? To
your
that
what?
stereo, your Discman, your Sony Discman or your Sony Walkman. You can get that to your radio in one of two ways. You take that little tape deck thing and you plug it in your tape deck.
Wow.
Or
Throwback Thursday.
Or you plug it into this other little device that goes into your cigarette lighter, and that is effectively a small FM transmitter.
Right.
It's in the FM broadcast band, and you do not need a license to broadcast low power
Up
FM
to a
radio.
certain power.
Up to a certain power output. What that power
Any
output is, I don't
channel?
remember.
Any channel?
Anywhere
it's
in the
any
FM.
channel.
Yep. Any channel in the FM spectrum and the terrestrial broadcast spectrum.
Gotcha.
That's effectively what the RPi TX project did on the Raspberry Pi. Galen also tuned it so that it's well within the bandwidth reception capabilities of the RTL SDR. So the very inexpensive software-defined radio receive only, which isn't super capable, but it's capable enough
To receive an FM transmission signal
Yes.
on the RTSDLR.
Yep. Which has the
Take the
encoded data.
analog radio waves and
Yep.
translate that into digital.
Yes.
Oh, that's really cool.
Yes. All right. So, guys, if you don't mind showing my screen just for a moment here, we'll just recap some of this stuff because there's a few other things that I want to put up there.
This is really cool, but it's just making me laugh because this is stuff I worked with 30 years ago.
Yeah, it's
And
scary,
it wasn't
isn't it?
new then.
Right. Well, we've taken a little bit different approach in that it's inexpensive,
Yeah.
it's accessible to anyone, and we've done some custom things that have some interesting reliability to it. So obviously, we need to have physical access to plug in a box to get stuff. We didn't base it on any specific network-based attack, but when we thought about the initial attack, it was, hey, if we're going to break into an organization and we're going to put a Dropbox, what do we want to get out?
Right.
And our first choice was hashes from Responder.
Yeah.
So run Responder on a Pi,
Perfect.
and then send those hashes out so we can get those hashes, crack them, and then use them like on the VPN.
Yeah.
All right.
Beautiful.
Turn an internal into an external.
I like your attack methodology.
Hey, Larry, does part of your demo include an audio file so we can hear it?
Absolutely. I don't know if you'll be
Awesome.
able to hear it from Galen, but we should be able to make something work.
Because I was thinking, steganography, you should be feeding it into some sort of elevator music. So if somebody did monitor it,
That would
they
be
just
awesome.
You got to think application.
Yeah.
Yep. So our solution was using cheap stuff, hide in plain sight with something that's all around that people listen to that they don't necessarily think too much about. We actually considered using RDS. For doing the transmission. RDS is the ability to do data in standard terrestrial FM broadcast as a subcarrier. And that's how they get on some of the newer automobiles and such.
Oh, yeah.
Where you get the track information.
Yeah.
That's how they do that. But the data rate was incredibly slow for that. It was under 150 baud. So it was incredibly slow. So cheap, inexpensive stuff. you need to provide your own tool to gather info, write it to disk, and then we can use VaporTrail to encode that data and send it across the airwaves to be received. It's doing direct interaction with RPyTX, and if it's not necessarily... Galen, is this working yet, or is it one of those things that you were working on today? The direct encoding?
Or which part? Rather?
The direct encoding?
Right, that's not working just yet, so it's kind of still a two-step process.
Yeah, but you know what the problem is, and you know how to fix it.
Yes, exactly.
Gotcha. So one of the other things that we have is, because it's a transmit and pray type of medium, it's transmit only and receive only on the recipient end. We have no ability to provide acknowledgement that we've received a packet or any of that type of stuff. So one of the things is to make sure that there's some reliability is that we're going to be having the ability to replay the session over and over again. So if you have some data, send that data, replay that data again. And on the recipient side, we're going to be building the ability to, if you miss a portion of that data, it can reassemble it from the multiple transmissions. Because we can't request it.
You just have to
so
keep
we're just going to send it a certain period of time.
You keep receiving until your checksum checks out.
Exactly.
And then whether you missed a piece of data or a piece of your checksum's not going to check out. So you just keep receiving it until
it works.
Yeah, until the checksum works.
So then that becomes a little bit more complex. And Galen, I'm going to let you talk about specifically the digital mode and some of the ways in which we've done the ability to have some reliability.
All right. So the digital mode, it uses a method which is similar to FSK, which is
frequency shift keying.
Right, frequency shift keying, which encodes a signal using. It uses a very specific frequency that kind of the transmitter and the receiver both know. So data is being transmitted at a certain rate. The Raspberry Pi can't transmit data at any reliable rate, so I have to use something which is based on actually the signal crossing the center frequency. Whenever it goes from positive to negative or back, that's a new bit. And so on top, that's the low-level kind of transmission type. Then on top of that, I've built a way to kind of split up data into small blocks. And then those blocks form a larger super block. And everything within that super block gets a error correction recovery blocks generated from it. Now, from those error recovery blocks, as long as you have 16 blocks from that super block, you can recover the entire original data. But if more than 16 are corrupted, then you can't get anything out. But that doesn't help you recover in between blocks, super blocks, which is where retransmission comes into play.
Right. So effectively, we're using ZFAC for forward error correction,
which is kind of like error correction in hard drives,
which is very similar to those of you who have ever downloaded something from a binary news group, and
we would never do such a thing,
and leveraged par2.
Yes.
So, like, let's say one of the messages is missing, but you have all of the recovery blocks. You can use the recovery blocks to regenerate that missing block.
Gotcha.
So there's a bunch of that, and
that's pretty cool.
Galen, do you know how many blocks you can miss without and be able to regenerate with all of the recovery blocks?
Yeah, you can miss half of them, and then you'll be able to regenerate from there.
Right.
But that's adjustable just by changing a little constant in the code for if you have a less reliable data channel.
Gotcha.
Now, so what's your effective data rate transfer, which is kind of interesting because you're retransmitting, so you really don't.
Right.
You know what your theoretical data transmission rate is, but you may need to retransmit data multiple times, which effectively makes it the retrieval of the data slower, but your data rate is still the same.
Right.
Yeah.
So Galen, you said the current effective data rate is we were running at the demos at 2,000 baud.
Right.
It is possible to go faster, but it starts to be less reliable.
Yep. Now, that said, that's not, you can't just take the size of your input file, divide by that data rate, and get the time because of all the overhead involved.
Right. So the way Galen
has... how long does it take to transmit a few hashes? That's not a lot of data.
Not
exactly.
And Galen's going to demonstrate. He's going to do it.
What is that, like a minute or so?
Less.
Less than a minute.
Less.
So less than a minute.
Shut up and let Galen do his thing.
Yeah. The other one that is very helpful, too, is that on the receiving side, it's got some ability to do some automatic signal detection because the Pi can drift based on temperature, and so can the software-defined radio based on temperature. So it has the ability to sort of detect that center frequency should there be any movement when things are happening.
That's awesome.
And so, Galen, what did you write it in?
Haskell.
What the...
Right.
Wasn't that an 80s brother band?
No, that was Hanson. That was Hanson. Hanson. Which, if you look really quickly, Galen 90s. Could probably be a member of.
Is that like some kind of, is that like a strain of bacteria? Like I got a little Haskell on me. I had to get
exactly.
some antibiotics.
Yes.
That's what you want.
Yeah, you picked that up in Vegas, no doubt.
Probably.
Yeah. Now, the problem that Galen ran into in doing some testing for all of that is that Haskell only supports ARM7. So only on the Raspberry Pi 2 and 3 currently, and the Pi 0, correct?
No, because the Pi 0 uses the old ARMv6 chip.
Okay, so no Haskell on ARM6.
So what is Haskell?
It's a programming language.
Is that like Pascal, but with an H instead of a P?
It's kind of completely unrelated. It's more of a weird, started in academia and then migrated into industry over time. But I find that it's my favorite for writing stuff because I can get stuff done fast.
Is it object oriented or?
It's functional programming, so it's function oriented. Conceptually, everything is a function. Realistically, that's not how it actually works on the hardware.
Shouldn't everything be a function anyway? Is it?
I'll show you my function.
See, you don't have variables; you have functions.
What? You have indirect pointers?
Wait, so how do you store data if you don't have variables?
I mean, you do. It's just that you create functions that return data when given no arguments. And then the language, makes it look like a variable to you. So,
good Lord. But, so because of
that's like having if statements and not being able to do a conditional not.
Right. But so, Galen, you found this problem with ARMv6 and ARMv7. So you're going to eventually port it to what?
Either C or Rust, depending on how masochistic I'm feeling at the time.
C or what?
Rust.
Rust. I've heard of Rust, I think.
It's a thing you get on your bumpers
no,
in the car?
No, it's not a thing. It's a programming language of some kind. Yes.
It's like C, except it's supposed to stop seg faults, and it's pretty good at that.
Interesting. Seg faults are so much fun. Okay, go ahead. Continue. Please,
all right.
In the interest of time.
Yeah, so that's a lot on the digital mode. There was a lot of thought behind, hey, this is only a one-way transmission, so we need to make this reliable with some error correction and so forth.
That's awesome.
Yep.
I like
so we've thought about some things for the future, implementation in Rust and C, the possibility to add encryption into the process. Now FCC says you can't encrypt the data transmission, but there's no reason you can't transmit data that's already been encrypted.
Sorry, I'm still just trying to get over how you code in a language that doesn't have variables.
Move on.
I can't move on from that.
Yep.
There are no variables, Paul. Everything is constant.
There are no variables. These are not the variables you're looking for. Yeah. So some other stuff is that the transmission with toggling the GPIO with our Pi TX is incredibly noisy and inefficient. So we're looking at exploring building our own shield for the Raspberry Pi with an actual FM transmitter.
Not an NVIDIA shield.
No, not an NVIDIA shield.
Okay, that's a different segment.
So I've actually ordered some hardware to start down that path, and I'm not happy with it, but it's at least a start for a prototype. And the other ones is to potentially port to some other platforms like Windows 10 IoT, the Orange Pi, and the ability to do the real-time encoding like we are now on ARM7 with the ARM6 devices such as the Raspberry Pi Zero at $5. And the other one, the crazy super idea that I was thinking about, and we have no idea if this is even possible, we're effectively toggling the GPIO pin to do FM broadcast with the RPi TX project using pulse width modulation, so PWM. But on modern motherboards to control fan speed, they also use PWM. So I'm wondering if there's a way to directly interact with the motherboard to control fan speed from the operating system via PWM, so that you can conceivably use the PWM for fan control to do the same thing. We have no idea if it's even possible. That was one of those super crazy.
Would that make Galen a fanboy?
I think it would.
Yes, it would.
I see. So wait, Haskell is like Erlang. It's a functional. Sorry.
It works.
Yep.
Sorry.
It's functional. It works.
You got to move off of that.
I can't.
Come on, man.
I can't.
All right,
Let's
continue.
see the demo.
Yeah, so let's get Galen
I like
to
Jeff's
give
suggestion.
us a demo, and I'll have him narrate
Let's
as
hear
well.
the demo.
All right. I'm going to share my screen here.
Gentlemen in the back room, would you be so kind as to switch to Galen?
All right,
Yay.
here we go. All right, there we go.
We on?
We're on.
Sweet.
I see GQRX.
Yes.
I see an
So this
EKG.
is GQRX.
Yep.
And I'm going to be using this to decode the signal. So kind of the path the signals is going to take is it's going to come out of my Raspberry Pi. GQRX here is going to receive it and do the FM demodulation for me and send that data over UDP to my receiver, which is actually going to decode that data. So nothing going on here. That's just noise. And let's switch over here. So top terminal is the Raspberry Pi. Bottom terminal is my computer. And first thing we need to do is start receiving data.
I just want to say nicely done on the display that I can read that, and it's very nicely laid out. Thank you for
Yes.
that.
He's a badass.
So
Very nice.
Hey,
now
have you
we're-
heard of the super elite hacking tool called Tmux?
Is that like screen?
It is. It's exactly like Screen.
like screen, but you can split horizontally.
Whoa.
Sorry, man. I had to.
You're blowing
Anyway.
Paul's mind.
Yep.
So now this is receiving data and from GQRX over here.
Yep. So
And then
GQRX is sending signal over UDP to the receiver.
Exactly. So now over
So
here, I can
you know when
start
you're done
and I
transmitting,
just
but you
have
don't know if
yeah,
it's
what's up?
been received. So how do you know when you're done transmitting?
Just wait.
Yeah.
Okay.
So in this case, knowing when we're done transmitting is manual, and that's because streaming doesn't quite work yet on the decoder, and that's actually something that I'll probably get done in the next day or two. So I'll just transmit some words right now. So I'll just say, hello, everyone, I guess.
Should be hello
And-
world.
It should be Hack the Gibson.
Well, he does. There you go.
You're right. You're right.
Hello, everyone. I guess we should hack the Gibson. There you go.
There you go.
Thank you.
All right, so what this is going to do is this script I've written nicely wraps up encoding that and then transmitting that. So now that's transmitting, and over here we can look at the frequency spectrum as it starts.
Whoa,
sending the
look at
data.
that. Something just happened.
Drop bass in your face.
Wow. And unfortunately, Jeff, it doesn't look like we can hear it.
Yeah, I don't think Skype does audio over screen share. All right, so that's done, and then we can press
That's
enter
right.
over here.
I could tell the signal was going up.
So he had enter, it's
There
received
it
the
is.
transmission and
Wow.
decoded it, and sure enough, hack the Gibson. So not only
Applause, everybody.
not only
Yay.
does it work for ASCII-based transmission, we can also do binaries.
Yep.
Can you do GIFs, like animated GIFs?
Galen, take it away, my friend.
PNG. I think a GIF might be
I
a
was
little
hoping
large.
for an animated.
Well, it's 2,000 baud. We want the demo to be done today.
All right, so I've got this large-ish PNG file that I'm going to receive. And so in this case, for the receiver, I'm going to tell it to dump the output to a file.
Instead of
And
to the terminal.
Like,
Yep,
yeah,
Hack the
yeah.
Gibson. Yeah.
Transmitter, I'm going to
PNGs
bring
don't
it
look really
to
great
file.
in the terminal.
Not quite. And so now that's encoding the PNG. And once it barfs on our screen, then it started transmitting. There it goes.
GQRX. Yep.
There we go.
So this one does take a little bit longer because the
it's more
size is a little
data.
larger.
Yeah, this one will take roughly twice as long.
Yep, and the reason why it takes twice as long from just a short period of text to the PNG, which is larger, there's a lot of padding and all of the addition of the recovery blocks.
Yes.
So
Yeah.
there's a minimum
Larry,
block
serious
size.
question. I
Yes.
mean, obviously, if you were monitoring this, you would see the activity, but your contention is nobody's just monitoring this frequency. Right?
Exactly. All right, so he received a PNG.
I would say in the on the spectrum of what people monitor, pun intended, in terms of radio frequencies, that FM transmissions fall somewhere like on a scale of 1 to 10 in like -50.
Yes, exactly.
Okay.
But
this is just the beginning, because you can reinvent frequency hopping next.
Conceivably. And Joff
That's a great point, Jeff. Great point.
Joff had a
something?
comment back there.
Oh, my comment back there was on the spectrum of frequency monitoring. That is true, except if you're Jeff Mann or anybody else with a signals background, then you sure as shit are going to be monitoring it.
Yep.
So you can see I actually have wrong size here, and what that means is that it missed the second block. And this is why retransmitting is important, because even with the error correction, the pi is kind of not that great, so being able to retransmit ends up being really important.
Yep. So we're effectively going to do a repeat of the transmission manual.
So you need to broadcast it several times and
Yep.
It's like a
until you
network
get
with
some
a lot of
confidence that you can
retransmissions or collisions on back when we had shared hub networking.
Right.
It was slower.
But of course, we have no ability to say, hey, there was a collision or we missed one.
Yeah.
So
you just
You just have to wait.
Right. So
even
for the
slower
purposes
than
of the
that.
demo,
Yeah, I
I'm
gotcha.
telling it to retransmit manually, but in a production environment, this would actually just be looping on a script.
So Larry, you had gone to the trouble of saying what the FCC does in terms of regulating FM. Have you looked into the other frequency ranges? I mean, are they also regulated, or?
So yes, we can do anything in the industrial, scientific, and medical band, which is like, hey,
that you could have chose a better. Never mind.
I could have.
he did. Well, he had a better one before, and I liked it.
Paul wanted to see boobs.
Good enough.
I wanted something with high resolution and low file size, and you're limited on
no,
colors
that
when
makes
you do
sense. That makes sense. But conceivably, you could use 2.4 and just do your own, not 802.11, but you can use the 2.4 gigahertz spectrum because it's an open frequency to do transmission.
Yes, absolutely. But
It's more likely to be monitored.
Yeah,
exactly.
Well, it might look weird
more likely to be monitored with spectrum analysis, especially with folks that are doing 2.4 gigahertz networks.
But you need to do spectrum, not 802.11 monitoring like most people do. You need to do spectrum analysis.
And then when we do this, and
Look, what was that tool? Y-Spy?
Yep. When this stomps all over someone's wireless network and also it gets interference from someone's wireless
You're
network,
going to draw attention to yourself.
or not have a reliable transmission. Because in this case, we've picked an FM broadcast range that is not in use.
Right.
So there's an
issue
anomaly
is,
there. Go ahead, Galen.
How far off is FM from the Wi-Fi 802.11 frequency?
What frequency?
Frequency range for FM is between like 88 and 108 megahertz, and
What's
Wi-Fi
Wi-Fi?
is
2.4
2.4 gigahertz or 5.8 gigahertz.
Yeah,
And the pi can't even get up that high.
Yeah.
No.
Yep.
But I'm thinking go in the other direction. Go HF, go MF, go LF.
Yep.
Yep,
Yeah.
absolutely. So we can go
Or
down to
VLF.
Galen. The pi will actually transmit from what frequency ranges?
According to RPITX's README, 5 kilohertz to 450 megahertz. So we can get way down there.
5 kilohertz. Yeah. That's,
Yeah.
Yep. But and so Jeff, yeah,
That gets
absolutely.
you into the VLF range. I mean, because the lower frequency, the more distance you have to cover.
Absolutely.
So wait, sorry, lower frequency penetrating through walls or concrete is better. Correct.
Yes.
Better.
Yeah, okay.
And over longer distance, even with open line of sight. The other
I have
one,
this conversation with my wife all the time because she's ultrasound tech. So we talk about
This is
frequency.
when I was a kid, Paul, and we used to listen to AM radio. Like on a weekend night, we could turn on the AM radio, and I lived in Maryland and still live in Maryland. We could sometimes pick up radio broadcasting from Chicago.
Yep.
On the AM range.
Right, because it would do skip and either skip off the ionosphere or bounce off of clouds.
And AM gets a lot better range, but the Raspberry Pi can't do amplitude modulation. The hardware is just not capable.
Right, because it's the toggling of the GPIO pin for the square wave.
Oh, okay.
Yep.
Well, what's Pi good for then?
Yeah, exactly. So, Jeff, I know you're going to ask the question, what's the distance? And well, quite honestly, we didn't test the distance, but based on some feedback from
we were
other
out
folks
in the desert.
I
and
know,
stuff.
but based on the feedback from other users of our Pi TX, that we didn't develop. We're talking potentially 100 meters or longer. One of the gentlemen that we ran into said he hung this off of his apartment building in downtown LA and was able to cover an entire city block in LA, which is pretty good. But because the hardware is so cheap in both cases, you can plug an RTL SDR into a Pi with your cheap piece of wire and have VaporTrail do the reception right to a directory, and then VaporTrail says, oh, hey, this file's in this directory, and can transmit it. So you can create a repeater for under like $35 type deal.
And you just need to be in the parking lot, essentially.
Right.
Or somewhere close by.
Right. Or find some place to drop a repeater that you can power off of USB battery.
And have a 4G connection back to
Or
like another
anywhere.
Pi or whatever.
Yeah, multiple layers of repeaters.
Well, and isn't that an advantage of FM as well? Because at that frequency, you're actually going to get through walls a little bit easier than, 2.7 gig. Sorry.
Yeah, it has a tough time
4
with
gig.
walls and people.
When 2.4 gig hits walls and trees and crap, it gets absorbed. So.
Yep. The only detractor, Joff, is that for the FCC, for the consumer, you can do so low power that it's also a challenge there, because the 2.4 gigahertz stuff is significantly higher. 1 watt indoors, 4 watts outdoors.
Yeah.
Max.
So now all your code is available in open source?
Absolutely.
Hey,
Absolutely.
What's a watt between friends?
That's
I
true.
know. What? What?
What?
Yes. Yeah. So absolutely.
One of my jokes.
So Galen, awesome demo. Thank you. It
Good job,
works.
Galen.
It
Good
works.
job, Larry.
Hey,
And,
Galen,
so
that was awesome.
real quick,
We're looking
gentlemen,
forward
if you
to
go back
you
to my screen
replace
share.
Larry on the show.
Yeah, if you got give my screen share real quick, yes, to give you guys.
who did the awesome graphics for your presentation?
I did.
Good job.
Oh, that was Larry.
Yeah, so if you guys.
Wow, that is spectacular, Larry.
Wait a minute. So, absolutely. So this was the end of our thing. I don't know why there's the animated GIF. All right, so now time for us to meet and greet and talk to people about, questions, and even better. And then it goes to the final slide.
So, yes.
Yeah, so VaporTrail.io, it gives you it's a really cheesy website. I did Notepad. So it talks about a little bit about the project and gives you the link to the video of this presentation. We left the file size small so that you can see all the slides and you can press pause if you want to read it. As well as a link to the VaporTrail project.
Did you create all those
GitHub.
graphics?
No.
You stole them from somewhere?
Well, they came from the internet.
Pretty sure those are stolen. Yeah.
Those are screen caps from the My Little Pony show. They really are. And VaporTrail, this pony with the glasses.
But they
That's
exfiltrated
VaporTrail.
it over FM.
Oh, wait, the character's name in the show is VaporTrail?
Yes.
Oh, my God. That's
Galen is a huge fan, and he was the one that did all the work. So we named the project after something he's a huge fan of.
Is Galen going to stick around for the next segment?
It's entirely up to him.
Segment.
We're
might be
gonna
past
news
his
stories, and it's going to be raunchy and hilarious. And I think you have the great wit for it.
Sure.
All right. With that, VaporTrail.io, we're going to take a short break, come back, and talk about security news for this week. Stay tuned. Don't go anywhere.